So here in this lesson, we are going to add some the smooth movement in the player. So as of now, you can see the player movement is kind of stationary, or kind of, the it only move as we press the keyboard A and D. But we are going to add some smoothness to the player movement. So for this, we have like the smooth damp function. All right, so it will basically, what it means, like, we need to reach to the target velocity or target value from the current one. All right, so this will take some few parameters, like it will take the current, target, current velocity, smooth time, and max speed delta time. So this means this one is the current value. So for example, if the target value is the value that is pressed by the player, all right, the value of A and D, and if we reach from the current value to the target value at some time, in some smooth time, obviously that will make the velocity smooth. All right, so it gradually moves the current value toward the target value over a specified time at a specified velocity. So it does not instantly move the current value to the target value, but instead it gradually moves the current value towards a target value. For example, so we can use like this: Mathf.SmoothDamp. So there are some parameters. So there is one array of keyword, and we are going to use like this. So okay, so let's do some rearrangement. We need to change some of it. For example, if we are using the Mathf.SmoothDamp, so first let's so if this one is the target value, okay, not the target velocity, so let's change its data type to float. Okay, so let's make another variable known as current velocity, and let's make another one private float velocity ref. So okay, I will tell that a bit later. All right, so we don't need this as well. So the target velocity will be, so not the vector type, vector input, it should be like horizontal input into speed for now. So this will return the float value and assign to the target velocity. So, and let's use the mathf dot let's use the mathf dot SmoothDamp. All right, so it will take the parameter, the current value. The current value is the current velocity, and the target value is the target velocity, as well as the ref keyword. Ref keyword means velocity ref, comma, smooth time. So have we created the smooth time? No. Okay, if that's so, let's create one smooth time, means serialize field float smooth time. So let's initialize this value as 0.1. Okay, so we will create it as smooth time. So, and obviously it will return the value. So let's assign that value in current velocity. All right, so basically now we need to use the current velocity. So this transform the translate will take the vector3 input. Okay, so either we can pass as a vector3, or you can directly pass like something like that, like current velocity, let's multiply it with time dot delta time, and we don't need any translation in y and z. Okay, so let's review this code. So basically this target velocity will be the float, it will take the float returns of this value, since the target velocity is float data type, and the current velocity. Okay, so this will basically, okay, so if you get the problem, okay, so this one is smooth, means this will reach the current velocity to the target velocity over the time 0.1, and this value means it will, the calculated value will be stored here, and it will assign automatically to the current value, and and it will, the result will be returned to the assigned to the current velocity. All right, so after that, after using this, the we have used the current velocity as transform the translate. So since we do not need the any translation in y and z, so we set it as 0. Okay, so let's test it. So smooth time is 0.1. That's good. So now if I play, okay, so as you can see, this one is a very good smoothness. So I can see the difference. As you can see, I am releasing the keyboard press, but still I am getting the smooth movement. So this much for this lesson. So thank you very much. See you in the next video.